15, problem number 15 states that there are 5 boys and 3 girls. In how many ways can they stand in a row so that no 2 girls are together? Okay, so there are 5 boys
5 boys and 2 girls.
and 3 girls.
Oh, 3 girls. Sorry.
Okay, you are making them stand in a row. Okay, so that no 2 girls are together. Now here the language is very important. That is, the language here is no 2 girls are together. So you have to understand the difference
Two
between
boys standing
saying
together.
no. That they have to understand the difference between the language when it says no 2 girls are together and when it says no girl is together or none of the girls are
Ah,
together. Okay, there's a difference in both the languages. So first, let us see according to the language that is given here. The language here is no 2 girls are together. So and there are 5 boys. So what you do is you place the 5 boys first. Okay, let's say let us denote the boys as say B. I place these 5 boys first in the 5 places. Okay, so 5 boys can be placed in 5 places in
yes, sir.
5p5 ways, which is factorial 5 ways. Okay, so 5 boys can be placed in factorial 5 ways. Next, what I do is the girls can now be placed in these places. This place, this, 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 or this. How many places are there? One, two, three, 4, 5, 6. There are 6 places. And how many girls are there? There are only
3.
3 girls. So 3 girls can be placed
And 6 places.
in 6 places in 6p3
6
ways.
people.
Okay, so therefore the number of ways in which they can be placed, in which the number of ways in which the girls
5
are
to 5.
no 2 girls are together, it is 5p5 into 6p3.
6 p3.
That's what. So you calculate this 5. This is factorial 5 and 6p3. How is it calculated? 6p3 is calculated
6 into.
as 6 into 5 into 4. Okay,
And it-
so this is how you calculate. Factorial 5 is 5 into 4 into 3 into 2 into 1,
you will do
and
that.
this is 6 into 5 into 4. That's it. Okay,
120, 30, 360, 360 into 4.
so that is you calculate this whatever
140,
it comes to.
144.
Okay, whatever it comes to. Now
144.
now we come to the second part where I said that language may be a little different. Okay, uh, here suppose it is said that none of the girls are together. If none of the girls are together, then in this case what should I
Answer
do?
should be the same thing.
No, that is why I
Because
said, because the language is different here. None of the girls are together. So in this case, see what is the difference here is. See, there are
there
5 boys.
also.
See what I mean is that none of the girls are together. That means that a girl and a boy can stand together. Understood? That none of the girls are together. That means not all the girls are together. Understood? Here the language was no 2 of them.
It means 2 girls can stand.
Yes, but all the girls
Two
cannot be
girls can
together.
stand. Oh, all the 3 can't be together. Oh,
Yes, all the 3 cannot stand together. So in this case, what you do is
okay.
you have your boys here, and then say you have your girls here, 3 girls. Okay. So now what you do here is these 5 boys,
Okay.
you consider this all the 3 girls as one. Okay, and there are 5 boys here.
One.
There are 5 boys, right? So what is the total comes to? The total comes to 6, right? So without if you consider without any restriction, without any restriction, the boys and girls can be arranged among themselves in
6 factorial.
In factorial 6 ways or 6p6 ways, right? Now what you see, since you have considered all the girls as one, the girls can now be arranged among themselves in 3p3 ways. The three girls can be arranged among themselves in 3p3 ways equal to factorial 3 ways. Okay. So in how many ways are the girls always together? Therefore, number of ways in which the girls are always together. See, there are how many in total? Five boys and three girls, right? So they can be arranged among themselves in 8p8 ways, right? Sorry, this is not here. In the next step, we'll do. Number of ways in which the girls are always together is factorial 7 or 6p6, not factorial 7, 6p6. This one here, okay, and into 3p3. In this way, the girls are always together. So this is equal to factorial 6 into factorial 3. Now what happens? Therefore, number of ways in which girls are never together. Total how many people? Boys and girls? There are 8, right? So they can be arranged among themselves in 8p8 ways. Okay, without any restriction. Minus number of time they are always together. Number of time they are always together is factorial 6 into factorial 3. So therefore, this is factorial 8 minus factorial 6 into factorial 3. Number of ways in which they are always together and without any restriction. And how many ways can you arrange them? Factorial 8 ways. Okay, so that is what. So there is a difference when I say no two girls are together and when I say none of the girls are together. That is what you must realize the difference. Okay, let's see another problem here. Okay, so the next problem that we are going to deal with here is before starting with the next problem, the next concept actually is that if suppose I have three identical things, three colors, say I have three red colors, okay, I have four blue colors, and I have say two green colors. Okay, now the question I pose to you here is that in how many ways can they be arranged among themselves? See, these three things are identical, right? Three are identical, right? Not all are different, right? Four are identical here. And how many identical here? Two. And what is the total number here? 3 plus 4 plus 2, which is 9 factorial, right? In such a case where a certain number of in certain number of things are identical, okay, where only a certain number of things are identical. Who sent? In such a case where you have certain number of things in which some are identical, then the number of arrangements in this case would be total how many? There are 9 articles or 9 things. And how many identical among them? There are 3 identical. So you divide by factorial 3. How many 4 identical things? So divide by factorial 4. And then again you have 2 identical things. So in this case, when certain things are identical, then the number of arrangements is you take the total number. Okay, so n factorial divided by the, in fact, the formula here is factorial n, where n things, out of which p things are identical, factorial p, q things are identical of the second type, r things are identical of the third type, and so on. This will continue. If there are other identical things also, that will continue. For example, let us say the word India. In how many ways can you arrange the letters of this word India? Okay. In how many ways can you arrange the letters of this word India? If you see here, there are 2 I's, right? One N, one D, and one A. So if you see, there are 2 things that are identical. So therefore, number of ways of arranging is how much? First of all, how many letters? 1, 2, 3, 4, and 5. So factorial 5. And how many identical? There are 2 identical. So by factorial 2. That's it. So this is 5 into 4 into 3 into factorial 2 divided by factorial 2. So you cancel, you get 60. The number of ways of arranging the letters of this word is 60. Is this clear? This is a very, very important formula in which permutation of n things or arrangement of n things in which p things are identical of the first type, q things are identical of the second type, r things are identical of the third type, and so on. So now once we know this, let us do this problem here. Number 19. Okay, 19.1 and 19.2 both. First of all, let's say 19.1. So what is the given word here? How many, question here is find how many arrangements can be made with the letters of the word mathematics. The given word is Mathematics. This is the given word. And what are the letters? See, M, how many M's? There are 2 M's, right? How many A's? There are 2 A's. How many T's? There are 2 T's, right? How many H? Only a single H. How many E? There is only a single E. Okay. How many A is already dealt with? I've got dealt with T also. How many I's? Only a single I. C is also single. S is also single. So therefore, what is the number of arrangements here? How many letters in this word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial. And how many things that are identical? There are 2 things that are identical. So you have for 2 M's, you have a factorial 2. For 2 A's, you have a factorial 2. And for 2 T's, you have a factorial 2. That's it. In this way, you can arrange the number of letters. Now you can calculate in whatever way you want. Okay. The next question is, in how many of them the vowels occur together? Now this is the main question. The vowels occur together. Okay. So what are the vowels? The vowels are, see, A is a vowel, but it is repeated. So I'll write A. What is another vowel? A is a vowel. Okay. And I is another vowel. These are the vowels. Okay. So number of ways in which the vowels can be arranged among themselves. See, now look at the question here. Before thinking about that, in how many ways can the vowels occur together? Okay. So what you do here is you keep the vowels together. Say I write here. Okay. Then TT. Then H. Then C. Then S. And I am keeping the vowels together. A I am keeping together. E I am keeping together. And I am keeping together. Okay. So now look at this. Look at this as a single entity. Okay. So how many letters are there here? 1, 2, 3, 4, 5, 6, 7. In how many ways can they be arranged?
Hello?
Yes.
Yes, sir.
Now see here, we have 7 letters here, right? Considering this as a single entity. And also you consider this as a single entity. So what happens? You have 7 letters here and you consider this as a single letter, one letter. Okay. So how many total letters? You have 8 letters. Just as we had done in the boys and girls problem, remember? That way. But there will be a slightly different because see, therefore number of ways in which the vowels are always together. That is the question, right? Always together. 19.1. Yes, vowels occur together. Number of in which the vowels are always together or occur together. First, how many letters here? 8 letters. So factorial 8 divided by how many identical here? There are two m's here, right? So I divide this by factorial 2. There are two t's here, so I divide this by factorial 2, right? Into now see that the vowels can now be arranged among themselves in how many ways? 1, 2, 3, and 4 vowels are there. So factorial 4 divided by 2 is identical, so factorial 2. So in this way, the vowels will always be together. Now, if the question was the vowels are never together, then what would you have done? If the question was that the vowels are never together, then if the vowels never occur together, then what would happen? How many arrangements without any restriction? It is factorial 11 by factorial 2, factorial 2, factorial 2, right? Without any restriction. Factorial 2, factorial 2, factorial 2. And so you subtract from here the number of arrangements in which the vowels are always together. You subtract from here in which the number of arrangements in which the vowels are always together. That will give you the number of ways in which the vowels are never together. You can simplify this to write 1 by factorial 2 cube into factorial 11 minus factorial 8 factorial 4. Now you can calculate this in any way you want. Okay. Now remember, all these were permutations in which we were not repeating. Okay, non-repeated permutation. Let us see the next one, which is again an ISC problem. Which is your number 17. How many 7-digit numbers can be formed with the digits? Okay, so 7-digit numbers. What are the digits given? 1, 2, 0, 2, 4, 2, 4. So how many digits given? 7 digits are given. And you need to form how many digit numbers? 7-digit numbers. So your number will look something like this. Right? So how many 7-digit numbers can be formed? See here that without any restriction, these 7 digits can be arranged among themselves in how many ways? Divanjan, can you tell me in how many ways?
Sir, 7 factorial.
Yes, but there's a catch here. You see, 2 is repeated.
Yes, sir.
Then, what for the repetition?
4
What will
is
you do?
also divided by
In
uh,
how many ways? 7
Divide by
factorial.
2.
Yes, divide. You see how many ways two is repeated? Thrice. So divide by
3.
factorial
Right.
3. Any
3
other? Yes,
factorial.
4 is also repeated here. So
4
factorial
is repeated. So
twice.
into
So
2
factorial 2.
factorial.
none other is repeated, right? So without any restriction, you can arrange it
Sir,
in this manner. Yes.
so if we will expand 7 factorial, then it will then cancel too.
Yes, yes,
3
you can
factorial
calculate.
and
Yes, yes,
then
you calculate in whatever you know what factorial is. So I'm not calculating because that will be a wastage of time. Okay, I'm simply showing you the number of ways. You know how to calculate factorial. Calculation of factorial is very easy. Now, now the problem here is that what about those numbers which have zero here? Then what will happen? Right? The numbers that begin with zero cannot be 7-digit numbers, right? This includes what? These number of arrangement, they include numbers that begin with zero also, right? So I need to
yes,
remove those numbers that begin with zero, right? So what you do is you fix zero in this place, right? How many places are left now? 6 places, right? So fixing zero, fixing zero at the first place, 7 digits, in fact 6 digits, uh, 6 digits can be arranged. And how many places are there? If you are removing this zero, you're already putting this zero here, right? So how many digits remain? 6 digits remain. And how many places remain? 6 places remain. 6 digits can be arranged in 6 places. In how many ways? Factorial 6. Again repetition. Factorial 3. 2 is repeated twice. And 4 is repeated. 2 is repeated twice. And 4 is repeated twice. So therefore, number of 7-digit numbers will be how many? Without any restriction, how many were there? Factorial 7 by factorial 3, factorial 2. These included these numbers, right? This included this number of ways. That is the number of numbers that were beginning with 0. So you subtract this. Okay, so now this becomes, it's very easy to calculate this one. Factorial 7 minus factorial 6. You write 7 factorial as 6 into 7 into factorial 6. Minus factorial 6. Now you can take factorial 6 common, and by factorial 3, factorial 2, and this will become 7 minus 1. So this is 6 into factorial 6 divided by factorial 3 into factorial 2. Now you can put factorial 3 as 2 into 3, 1 into 2 into 3, 6 as 1 into 2 into 3 into 4 into 5 into 6, and then cancel and then get your answer. Okay, so that is how you calculate this. So that is what. Now these are our number 22. You can do on your own. Commission and all that I have already shown you. India I have already shown you. Okay. In a similar manner, you can arrange the letters of the word Allahabad also, Chandigarh also, and commission also. You can do very easily. Okay. Let us do one problem that is a little twisted one. In this case, I'll consider repeated permutation. Whatever problem that I have done till now, I have done for non-repeated. That is, you cannot repeat the objects. That is, even if you are forming numbers, then you're not actually repeating the digits in the numbers. For example, suppose you are forming from these digits, 4 digits, you are forming 3-digit numbers. Till now, whatever we have done is that if we are using 2 here, then you cannot use a 2 here, or you cannot use a 2 here. That means once you have used a 2, you cannot use 2 here. You cannot use a 2 in this position also. This is called non-repeated permutation, as I told you. Let us see one example of a repeated permutation. Now, what happens in a repeated permutation? Okay. Yes, number 24. How many numbers are there in all which contain 5 digits? Now, 5-digit numbers, see, 5-digit numbers will look something like this. And they are formed with the digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, 10 digits. If you put in each of these places, you will get a 5-digit number, right? But the point here is that they have not said that it can be repeated. See, if I put a 2 here, I can put a 2 here also. 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 So this is also a 5-digit number. But till the last problem that we did, these were where you could not repeat. That is, if you have put a 2 here, then you could not put a 2 here. You could not put a 2 here or here or here. Okay, but in this case you can. So in this case, what should be the number of arrangement? This is called repeated permutation. In this case, what should be the number of arrangements? Now see here, first of all, in this place, units place, in the units place, there are 10 digits given to you. 10 digits can be placed in the units place in how many ways? 10 ways, right? Similarly, now come to the tens place, 10 digits can be placed in the tens place in how many ways? Again 10 ways, right? Similarly, 10 digits can be placed in the hundreds place in how many ways? Again 10 ways. Again 10 digits can be placed in, now this place I have already filled. Okay, this is your hundreds place. Thousand place in how many ways? Again 10 ways.
Hmm.
But in the last place, in the 10,000th place, 10,000th place,
Yes, sir.
yes, how many ways? In this last place,
10 days.
no, this place I can place
9
only
only.
in 9 ways because I cannot place a 0 here. So therefore
Oh,
9 digits.
okay.
So 9 digits can be placed in this place in 9 ways. Therefore, what is the number of ways? Total number of ways? 10
10 into 10
into
into
10 into 10
into 9
into 10 into 9. So this is
into
9
9.
into 10 to the power of 4. This is the number of permutations. See that the number of permutation has gone up exponentially. Very high number of permutations you are getting if the digits can be repeated. Okay. So that was one example from your repeated permutation. Okay. So I think permutation I won't do much. Okay. Let us start with combinations. There are some more interesting problems. Circular permutations has already been excluded from your syllabus. Okay. Circular permutations are no longer there in your syllabus. Okay, and there were one or two more interesting problems which I would have liked to solve, but it's okay. Unless you have any specific doubts, I think that should be it. Okay, if you have any specific about doubts, then you can ask. Otherwise, for the formal classes, this should be sufficient. Okay, now let's see what about the combinations. Okay, combinations. Let me just uh, write here a little. Combinations. Just understand the concept. Combination is very important. Combination more important than permutations. Combination is synonymous with the word selection. Okay, now the question is, what do you mean by selection? Suppose I have three students here. I have Devanjan, I have Tanisha, and I have Sumit. Three students. Now the question here is, in how many ways can I select none of you? I don't want any of you. Then in how many ways can I do it? In only one way, right?
One
Yes,
way. Yes, sir. One way.
only one way. I will simply say, okay, fine, I will not select. Only in one way, I can refuse to select any of you. So I can select none of you in how many ways? Only one way. So selection of
One.
three students taken 0 at a time is only 1. Okay. Selection of, next I say I will select only one student. Selection of one student taken, selection of three students in fact. Selection of three students taken one at a time. Now I want any one of you. In how many ways can I do it? I can either select Devanjan, or I can select Tanisha, or I can select Sumit. So how many ways can I do it? 3, right? Next,
3 ways.
selection of three students taken two at a time. In how many ways can I do it? I can either select Devanjan and Tanisha. I can either select Tanisha and Sumit, or I can select Devanjan and Sumit. So in how many ways? Again, 3 ways.
3 ways.
And selection of three students taken three at a time. In how many ways can I do it?
1
Only
way.
one way. I can select all three of you.
2 ways.
Okay. So that is what combination actually means. Now here see, one way I have written, the combination is denoted by C. Okay. So selection of three students taken 0 at a time is denoted by 3C0. The value here is 1. I'll show you how to calculate the value later. But selection of three students taken 0 at a time is denoted by 3C0. Selection of three students taken 1 at a time is denoted by 3C1, which you calculate the value to be 3. Selection of three students taken 2 at a time is denoted by 3C2. We'll show this to be equal to 3 later. And this is denoted by 3C3. Okay. That is what combination means. Now, what is the relation between permutation and combination? Now, see, permutation is denoted by NPR and combination is denoted by NCR, right? Now, permutation is what? Permutation is the arrangement. After selection, we are arranging. That means the number of permutations. Suppose I select, so consider this case where I am selecting two students from three students. Okay, so I select two students. Suppose I select Devanjan and Tanisha. Suppose I select these two. Okay. Now they can be arranged among themselves in how many ways? Factorial 2 ways, right?
2 ways.
So therefore, what
Yes, sir.
happens? What happens that selection, after selection, that is three students I am selecting in 2 ways. In how many ways I am arranging them? In factorial 2 ways, right? This is denoted by 3p2. Understood? Clear? First, I am
Yes,
selecting
sir.
two students. So two students I have selected. Now I can arrange among themselves in factorial 2 ways. That means the number of ways in which I can arrange them is first select two students and then arrange them in factorial 2 ways. This must give us the number of arrangements of three students taken two at a
Oriented.
time. So therefore, the relation between permutation and combination is that NPR is equal to NCR into factorial R. That is what your relation between permutation and combination is. Therefore, from here only, therefore we are getting the formula for combination as NCR is equal to factorial N by factorial N minus R factorial R. This is the formula for combination. Now, combination formula you can use directly, or there is a shortcut to calculate combination from this formula. Suppose I give you to calculate 8 P6, then how will you calculate 8C6? Sorry, not P6. 8C6. Sometimes this is also written as, just remember, this is also written as C86. Sometimes this is also written in this way, 86. This is not matrix, okay? So whether you are given this notation or this notation, consider this to be 8C6. So how do you calculate 8C6? How do you calculate 8C6? Now 8C6 is very easy to calculate. If you use the formula, you will have 3 or 4 steps extra. Okay. But just as I gave you a direct method of calculation of NPR, I will give you a direct method of calculation of NCR also. In NCR, what you do here is that 8C6, you write this as 8P6. 8P6, how do you write? 8 into 7 into 6 into 5 into 3 into 2, right? 6 terms, and then divide this by factorial 6. That's it. Understood or not?
Sir, four
Yes,
is
sir.
missing.
Huh? Oh yes, 4 is missing. Okay, fine. 5 into 4 into 3 this should be. Okay, so you write this as 8p6 and then divided by this 6, factorial 6. Okay, suppose you have to calculate 7p2, 7c2. How will you calculate? First you write this as 7p2, that is 7 into 6. Okay, and then divide this by factorial 2. That's it. How you calculate combination in short. Now there are further ways of calculation, but we must first see the properties of combination in order to know the other ways of calculation. But the point here is that is the time up?